Hey guys, we are going to play that game. Is it ionic, covalent, or metallic bonding? And I'm just going to really quickly recap all the different ways that you draw ionic compounds versus covalent versus metallic. So, first compound, XEF2, what is it? It is covalent, and covalent compounds, we always start off with counting valence electrons. So xenon has 8. If you look at your reference table, that's the last number in the electron configuration. Each fluorine has 7. There's 2 fluorines, so overall we have 14 plus 8, which is 22. You have 22 electrons to work with. Xenon, there's only 1 of them, so it's going to go in the middle. Each fluorine is going to go on the side. And so far we used 4 electrons in the making of those 2 bonds. You always need at least a single bond between the elements. As a result, from my 22, I'm going to subtract 4 electrons because I just used 4 of them. And that means that I have 22 minus 4 is 18 left to distribute. So I can put my 18 around all of the elements. That's 6. That's 12. Each element only wants 8. So right now, xenon is left. We're just going to put all the rest on xenon. So xenon, so far that's 12 plus 4 is 16. So we need 2 more, and that makes 18. So that is covalent bonding. The second compound is ionic bonding because it has a metal and a non-metal. Ionic bonds like to have metals and nonmetals. Ionic compounds are drawn differently. They have ions in it, and the metal will always give up its electrons, all of them, to the non-metal. So lithium had 1 valence electron, but it gives its 1 valence electron to fluorine, and when it does so, it becomes positive. Fluorine now has 8 valence electrons around it. It gained just 1 electron, so now it's going to have a -1 charge. So that is representing ions because they have these hard charges. That's a +1 and that's a -1. The third compound, Ag, represents silver, and silver is a metal and there's nothing else, so it has to be just metallic. The way you draw this is really like you just have a whole bunch of silver cations, and then you have a whole bunch of free-floating electrons. That's what metal looks like. Okay, number 4, AgCl, silver chloride, is ionic because it has a metal and a nonmetal. And again, for ions, you're always going to have hard charges. The metal will lose all its electrons. In this case, silver is also +1. That just kind of works out because chlorine only wanted 1 more electron since it was in group 17. Everybody wants 8 always. So because chlorine gains the 1 electron from silver, it has a -1 charge since electrons are negative. So you steal a negative electron, you become negative. And silver likewise lost a negative electron, so it became positive. Okay, last compound is CO2, carbon dioxide, and that is a covalent compound because it has all nonmetals. And you could go through again counting and adding electrons. So carbon has 4 valence electrons. each oxygen has 6. So altogether, that gets you 12 plus 4 is 16. So always start with the single element in the middle, and the one you have more of is going to go around that single element. Have to always have at least a single bond connecting the middle element and the end elements. And because there are 2 single bonds, each one has 2 electrons in it, we're going to subtract 4 because we used 4. And you'll see that it doesn't work out when you try to put 12 electrons around both elements. So instead of going through and figuring out how many bonds to put, I know there has to be 2 bonds. So we're actually going to subtract another 4 because we just used 4 more. So 16 minus 8 brings us to 8, which means we have 8 left over. Carbon has 8 around it because of the electrons in the bonds. So we're going to put the remaining 8 on oxygen. And now oxygen also has 8. Everybody wants 8. We used the remaining 8, and now we're at 0. So that's just a quick recap of bonding, ionic, covalent, or metallic. Do I stop the recording?